You can either make it a same fraction here, or you can just do partial fraction. I think doing partial fraction is easiest. So I'm going to do the cover up method. If you are not too sure how to do the cover up method, you can just use secondary school method. For this case here, I'm going to put that this is A, R, A plus B, R plus 1, plus C, R plus 2. So the cover up method is this. If you want to find A, okay, the root of A will be R equals to 0. So you sub R equals to 0 everything and everything here except for the R here. So A is equals to 6, 0 plus 1, 0 plus 2. Then this will be 6 divided by 2, which is 3. Okay. Now then after that, I'm going to do B. B here, the R equals to minus 1. The root here is R equals to minus 1. So this case here, R equals to minus 1. Sub into everything but R equals to where you get the R equals to minus 1 from. So B would just be 6 minus 1 plus 2. It's actually minus. Then you have got the last one, which is C. So this part here, C is R equals to minus 2. So you sub everything into sub R minus 2 into everything except for the where you get for your C from. So C is actually 6 minus 2 plus 1. So very quickly, you will get this as 3, positive 3. Okay, so hence 6 over R plus 1, R plus 2 equals to 3 over R minus 6 over R plus 1 plus 3 over R plus 2. Carve out method. If not, you can just use the secondary school method. There are many ways to do this, so yeah. Now, when you do this kind of question, right, you have to know that for 3 terms and there's a difference here, it's definitely MOD. This is method of difference. When you have fractions, algebraic fractions like this, it's definitely MOD because APGP are exponential or linear. So whenever you see questions like this, right, it's definitely in your syllabus is confirmed method of difference one. Okay, confirm. Don't need to worry about it. Now, when it comes to method of difference, right, a lot of times students do not forgot that can use GC to see. Okay, so I'm going to recap that for you here. So for part 2 here, if you now remember, bring out GC, we need to go through this quickly. The first thing is n R equals to 1, you need from R plus 1, R plus 2, right? This is what you need, right? So you obviously use this one 6 here. You divide it by 6, you get this, right? So you just put R equals to R1, 1 over 6. 6R. The constant can be brought out 1. And then from here, 1 over 6. And R equals to 1. 3R minus 6R plus 1 plus 3R plus 2. Now for 3 terms, it's not easy to see the pattern. So what I encourage students to do is just use your GC. Bring out your GC here. Now it's not something you wouldn't know how to do lah. It's more of something you never thought of. You can actually use GC to list all these terms down. 3 over R. So you just put this as X here. Then you put this as minus 6, negative 6 over R plus 1. And then you get the next one, which is 3 over R plus 2. Okay, R plus 2. Here, key this in. Then what you do is you just second table. Okay, just key all this in, you get second table here. Then you just get this graph here. Okay, I'm just going to copy this graph over. This is our R. Okay, list everything down. Over 6. 3 minus 3 plus 1 plus 3 over 2 minus 2 plus 3 over 4 plus 1 minus 3 over 2 plus 3 over 5 plus 4 plus minus 6 over 5 plus half, and so on. Then the last one would be like, last 3 will be 3 over n minus 6. 1 plus 3n plus 2. Then after that, you have got plus 3n minus 1. 3n plus 1. Okay, so I'm just going to list this, the rth term for each. So this is r equals to 1, r equals to 2, r equals to 3, r equals to 4. So n minus 2. So for 3 terms, right, this part is easier to see because you have 1 minus 1 and minus 2 and 1 here. Okay, sometimes it's not so easy to see. So I will need to go through this with you. This is one. Oh, this is okay. Now, when you cancel it out, right, just use the LCM or denominator, like same. Denominator is important. So instead of 3 over 2 here, what you need to be able to tell, right, is actually if this is 4, this is 4. So this is actually the LCM will be 4. This is like 6 over 4. You should see this as 6 over 4. Okay. Because your calculator would just simplify it down for you, but you must know that this is actually negative 6 over 4. Okay, see this as this. Same thing for this junction. Okay, this one is good. This LCM is already 5. So you can see, okay, 3 minus 6 plus 3, this will be 0. Okay, this will give you 0 because 3 minus 6 plus 3 ma. So this will be 0 here. So this will be 0 as well. So this will be 0. So just know that this is how you see it. You look at the LCM of each. So this part here, this will be 0. Here 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 will be 0. Okay, you get that. So essentially, for 3 terms, take note, look at the LCM of the denominator. That's the reason why we call it denominator, right? Because it's usually it's the currency of the number there. So 3 minus 3, this is 0. Just check. 3 minus 3 is 0. We get 3 over 2. Okay. If you know how to use your calculator properly, right, in exam, right, it shouldn't be a problem because you already have an advantage. But it only comes in when you don't really know how to use your calculator. But please make sure you know how to use your calculator in exam. So this one, the numerator is the same, n plus 1, n plus 1. So 3 minus 6 will be negative 3. So this 2 will be negative 3 over 6. Negative 3, n plus 1, n plus 2. Then this multiply in will just be 1 over 4. Minus, actually you can just leave it like that. Okay. How do I check whether my answer is correct in exam? So say now I don't have the answer, right? How can I check my answer is correct? So you, in exam, if you want to check answer is correct, this one, once you cancel everything, really, hear me out. You key in calculator. Okay, so you key in your answer in 1 and key in the other one, the summation, the question in 1. So this is r plus 1, r plus 2, 1 to n. So you just summation here, math, press math, then go to summation. So this will be alpha r1, then the top put x. This is the important part. This is r plus 1. So this will be fraction 1, alpha r plus 1, r plus 2. Okay, so key this in your calculator. Then what you need to do next is to key this into your another one with your calculator as well, which is 1 over 6. Then you just put in 3 over 2. Then you just put in x. Your n here is x. Your big N here is x. This r is capital. So n, this will be 3 over 2 minus 3 x plus 1, then plus 3, then this will be x plus 2 bracket. Okay, key these two in. One is the answer, one is the question. Obviously you just go to the table. Your whole objective here is to make sure all your stars are aligned. So you see the one on the left and the right are the same, means your answer is correct. I don't even need to check the answer scheme. I know that this is definitely correct. So if you're asked to give a reason where it converges, meaning sum to infinity exists, so this value here, the reason why, so for part 3, as n goes to infinity, this is the reason, the one that I keep writing down, this is the reason. 3 over n plus 1 goes to 0. We know that because you take 3 divided over big value goes to 0, then 3 over n plus 2 also goes to 0. So hence, summation of infinity will just be r equals from r1, 1 over r plus 1, r plus 2. This one here will just be 1 over 6 r plus 1 summation infinity will just be, is it the same term here? Yeah, it's the same, right? This will be 0, so this will just be equals to 1 over 6. 3 over 2 minus 0 plus 0. This will just be 1/4. Okay, same thing. You can check your answer. Go to calculator, go to table value. You need to go down to very big value because you want it to be big. You know that in infinity, right? So you just table set. The table start you can put like say 100. Then you go to table. Okay, very slow, but you'll get it there. This is 1/4. All these are 1/4 here. These are 1/4. So same table set is here. So you go to anything table value that you want to change here is all table set. So second table start, as it implies where do you want it to start? 200, 500. You can just let it be that value there. 200 at infinity, you will realize that all the wow, this is very good. This is all 1/4. So you know that your answer is correct for sure. So let's look at part 4. Part 4 is like use your answer to find this one. So this one is obviously for part 2, right? This is actually just substitution. You know that you need to replace r as the bigger. Okay, you see this is an interesting one. The big value is r plus 2. This big one is r. The biggest is r. So meaning to say you want to change r plus 2 to r here. Okay, so it's quite okay lah. So in this case here, I'm just going to copy the part 2 solution down. So part 2, part 4, right? So this is by substitution. So from 2, we know that 2 is equals to 1 over 6, 3 over 2 minus 3 n plus 1 plus 3 n plus 2. Okay, this one here. So what you need now is r minus 1, r minus 2. Don't care about the boundary first. Boundary you can change later. Okay, so I think you know how to do it. I will just do it with you because I also want to go and do the questions behind later. So replace r as r minus 2 because we need to change it to r. The largest term, the largest factor here should correspond to the largest one. Okay, it's usually that's usually one of the telltale sign. So sorry, the largest one here will correspond to the largest one here. So r as r minus 2, you just replace it in. Remember, this is r as r minus 2. R minus 2, you get r minus 2 here. Replace r minus 2 plus 1 with r minus 1. This will be r. Then this is 1 equals to 1 over 6. 3 over 2 minus 3 over n plus 1 plus 3 over n plus 2. Okay, 3 over n plus 2. Then you remember you should replace this as well. So it's r minus 2 equals to n. R minus 2 equals to 1. So you start off with this case here. This case r. This is n plus 2. You make r the subject. Then this is r equals to 3. This is r minus 1, r minus 2. This is 1. Now this is just changing without changing the one on the right. Then we need to consider the boundary. So the first thing is I think the easiest is to change the UR first. Now we need to change this to 3 to n. Okay, 3 to n here. 3 to n. Oh, we already got 3 here. 3 is already done. So remember, lower boundary is the harder one to change. So if the lower boundary is the same as what is asking for, good job, because it's quite easy, this question. Now what we need to change is just a boundary, the top boundary to n. So replace n with n minus 2. So if you replace n minus 2, this will become n. So n. Okay, so this is a sort of a step by step, quite fast. 3 n minus 1, n minus 2. This is 3n. Oh, can simplify. I think the 3 can just simplify. 3 is very annoying lah. Just simplify. You can just multiply the 3 in. This 3, bring it out to be cancelled, will be half. 3. Okay. Check if your answer is the same as mine. 1/6.